vector A, this is vector B, and this is vector C. Okay, what is the direction of this vector? To get the direction of any vector, we can draw the coordinate axis. You know x, y, z axis. Okay, I'll draw the z axis also here. So we have this axis where x, y, z are axes perpendicular to each other. All the three are perpendicular to each other. Now can you tell me what is the direction of A, vector A, because we know vectors have directions as well. So what is the direction of vector A? Yes, vector A can be drawn like this. Vector A can be drawn like this. So we have vector A is in the positive x direction, right? What about vector B? This can be drawn like this. So we know vector B is in the positive y direction. What about vector C? See, vector C is like this. So it is neither in the x direction nor in the y direction, whereas it is in the xy plane. Remember, we studied coplanar vectors. So this vector C lies in the xy plane, in this plane. This is the xy plane, this plane. Okay, it is lying in the xy plane. That is, it has x component as well as y component. Okay, so let me give you an example of force. Let us say here is a toy car and it is pulled with the help of this thread by a child is pulling this. So force is applied in this direction. Okay, and is pulling this toy and the toy is moving like this forward. Okay, now see, this F force has two components, or we can say that the force is being applied in two directions. If it would have been only in the x direction, then it would have moved like this only. Okay, but if the force is being applied in this direction, right, that means it is moving forward as well as it is being pulled in this manner. That means it has y component also. So let's draw this in the xy plane. Okay, so this is x, this is y. I can draw force F like this. Okay, let us say force F is inclined to the x-axis at an angle theta. Okay, now I am dropping two perpendiculars on both the axes. Okay, so this perpendicular is equals to this part and this perpendicular is equals to this part. This portion is known as Fx, the x component of x, and this portion is called Fy, the y component of it. I can say F can be divided into two components, Fx and Fy, or I can also say that F is made out of two components. When you join Fx and Fy, you get F. Okay, so we say, how do we frame this? We call this as resolution of vectors. Vector F has two components, one in the x direction and one in the y direction. Okay, so these are the two components, Fx and Fy, right? So if I draw this vector F like this in the xy plane, okay, I am dropping a perpendicular on the x-axis and a perpendicular on the y-axis. Let us say this vector F is inclined to the x-axis at an angle theta. Okay, so this portion, let me name the triangle A, B, C, D. Okay, AB is vector F, AC is the component of F in the x direction, and AD is the component of F in the y direction. Okay, I am drawing these two triangles. This is A, B, C, inclined at an angle theta. Okay, we know and this also I will draw. Okay, or let it be like this, ABC. What is the value of cos theta? All of you studied trigonometry. What is cos theta? At this angle theta, cos theta will be this AC upon hypotenuse. Hypotenuse is F. Cos theta is AC by F. So I can write AC is equals to F cos theta. Taking F that side, AC is F cos theta. What is AC? AC is Fx. The x component of F is AC. So I can write Fx is equals to F cos theta. Right? Similarly, what is the value of sin theta? Sin theta is BC perpendicular upon hypotenuse, that is BC by F. Or we can write BC is equals to F sin theta. Taking F on the opposite side, BC is F sin theta. What is BC? BC is equals to AD, right? BC is equals to AD, that is Fy, the y component. Fy is F sin theta. Okay? So remember the x component, Fx, the component in the x direction, Fx is F cos theta, and the component in the y direction is F sin theta. Now, very important for you to remember, for you to understand that it's not always that Fx will be F cos theta and Fy will be F sin theta. Okay, very importantly, please try to understand this, that if this F is making an angle theta with the y direction, y axis. Initially, angle theta was with the x axis. Now angle theta is with the y axis. See. So here is F, this is angle theta, okay, and this is the x axis. Okay, so again this was B, C and D. Now what is cos theta? What is the value of cos theta now? Now in this triangle, theta is in this triangle, so cos theta is AD upon F, right? Cos theta is AD upon F. What is cos AD will be equals to F cos theta. Okay. Now see, AD is in the y direction. So Fy now is F cos theta. Okay. See here Fx was F cos theta. Here Fy is y cos theta. Why is this difference? Because earlier the angle was with the x direction. Now the angle is with the y direction. So I'll give you a simple trick. You don't need to get confused. It is very important, very easy to remember that wherever is the angle theta, okay, wherever, if angle theta is here, then this is F, this is 1 and this is 1 axis, okay. Wherever is the angle theta, that means F makes angle theta with whichever axis. Here F is making angle theta with x axis. So this component will be F cos theta, okay, and the perpendicular axis, perpendicular to this F cos theta will be F sin theta. This you have to remember, that the vector makes angle theta with whichever axis. On that axis you will have F cos theta or cos theta component, and the perpendicular component will be the sine component. If vector A, for example, vector A is making an angle theta with this axis, or I can have an inclined plane also. Need not be x and y axis, need not be always like this. I can have x and y axis like this also. And the vector is like this, for example. Vector P, for example. Okay. Now vector P is making an angle theta with this axis. So now quickly tell me, where will be the x component and where will be the y component? Right. Angle theta is made with y axis. So this will be P cos theta. Okay, and the perpendicular to this will be P sin theta. Okay, so we'll have much more practice so that you remember this properly, right? So let's try to prove this, whether it is true or not. Prove that mod of A is under root of ax square plus ay square. Again, vector A is inclined with an angle theta to the x-axis and this is the y-axis. Okay. So how to prove this? There are two ways. First is squaring both sides. If you square both the sides, then a square can be written as ax square plus ay square. Okay, it is square both sides. And then what is ax square plus ay square? A is the x component, ay is the y component. What is the angle between ax and ay? See, ax is like this, ay is like this. Angle between them is 90 degree. Okay, so can I write it as ax square plus ay square plus 2ax ay cos theta. Theta angle is 90 degree. Cos 90 between them. So that is what? Ax square plus ay square plus cos 90 is 0. So this whole term will reduce to 0. That is 0. So we get a square is ax square plus ay square, or a is under root of ax square plus ay square. Okay. This is what we studied in the parallelogram law of vector addition. Remember, this is one, and this is one vector ax, this is one vector ay. How to add them? Complete the parallelogram. This is the resultant. When we join the diagonal, make the diagonal, that is the resultant. How to find the resultant? That is under root of ax square plus ay square plus 2ax ay cos 90, 2ab cos 90, cos theta. So it's proved with that also. Okay, one more method can be to prove this. What is we have to prove under root of ax square plus ay square. So what is right hand side? Right hand side is under root of ax square plus ay square. What is ax? Ax is the x component. See, theta is made with the x-axis. So this will be a cos theta, right? And ay is the perpendicular component. So that will be a sin theta. So this square plus this square, ax square plus ay square. When you expand this, this will be a square cos square theta plus a square sin square theta. Can you take this a square common? Cos square theta plus sin square theta. Okay, and what is cos square theta plus sin square theta? That's 1. So this is under root of a square, that is a. So this is right hand side. What is the left hand side? A. So left hand side equals to right hand side. So we can prove it with both the ways. That means this is true. Magnitude of A is under root of ax square plus ay square. Okay. So let's take one practice problem. Let us say there is an object over here and it is attached to these 2 points. Okay. And with a string. So this string is pulling this object with tension T1 in this direction, and this string is pulling the object in this direction with tension T2. T1 is inclined at 37 degree, T2 is inclined at 53 degree. T1 is 5, T2 is 10. This is given. I want you all to do these questions in your copies, girls. Okay. So see, this is again simple. We can draw it separately. T1 is like this. This is T1. Okay. And this is angle 37 degree. So it's just you have to find the components. Find the components of T1 and T2. Okay. So T1 again has 2 components. T1 in the x direction is this. T1 cos 37 degree. Okay. And T1 in the y direction. Then perpendicular will be T1 in the y direction will be T1 sine 37 degree. Okay. Now how to find cos 37 and find sine 37, because we know cos and sine and tan and all those values for 30, 60, 90, 45. So what about 37 and 53? See girls, this is very important. Draw these triangles in your copy. You will always get these angles in your physics now 11, 12. So if this is a 90 degree triangle, this is 37 degree, this is 90, this will be 53 degree. Okay? I'll draw it bigger. Draw and learn this triangle. This is 37 degree, this will be 90, so this will be 53 degree. 37, 53, 90 triangle this is. And in this triangle, this is angle 37 degree, opposite side will be 3, opposite of 53 will be 4, and this hypotenuse will be 5. This is fixed triangle, it has fixed values 3, 4, 5, 37, 53, 5. How to remember? 37, if you ever get 37 as an angle, draw 37 triangle, just draw the 37 one. Okay, if you get 37. Opposite to 37 is 3. So the next will be 4, and this is always 5. If you get 53 triangle, okay, if you get 53 degree, then opposite to 53 is 4. This will be 3. This will always be 5. Remember, 37, 3, 53, 4. The remaining will be either one. Okay, so now you know this triangle. This is, let us say, 37, this is 53. This is 37, then this will be 3, this will be 4, this will be 5. So what will be T1 cos 37? T1 in the x direction is, T1 is 5, cos 37. What is cos 37? In this triangle, cos 37 will be 4 by 5. Right? So 4 by 5. 5 get cancelled. T1 in the x direction is 4. What is T1 in the y direction? That is T1 sine 37. So what is T1? Again 5. Sine 37. Sine is 3 by 5. So 3 by 5. This is 3. Okay. So we got the components of T1 in the x and y direction. Similarly, we can find the components of T2 in the x and y direction. This is T2. Okay, this is T2. This is angle 53 degree. Right? So this will be x component T2 cos 53, and this will be the perpendicular component T2 sin 53. Again draw the 53 triangle. This is 53, this will be 4, this will be 3, this will be 5. Right? So what will be T2 in the x direction? Will be T2 in the x direction is T2 cos 53. So what is T2? 10. Cos 53, 53 is this. Cos 53 is 3 by 5. 3 by 5. So 5 2s are 10. This is 3 2s are 6. Right? And T2 in the y direction is, see, T2 in the y direction is T2 sin 53. So T2 is again 10. Sin 53, this is 53. Sin 53 is 4 by 5 into 4 by 5. So 5 2s are 10. This is 4 2s are 8. So we got T2 in the x direction as well as T2 in the y direction. So this is how to find the component of any vectors in the x and y direction. This is one more important question which you will come across this year, like inclined plane question. So we have an inclined plane like a wedge whose angle is like this theta, and a block of mass m is lying on this inclined plane. Okay. Now resolve this component, this mass m, its force, into its components. So see, this mass m is lying like this on the inclined plane. So mg, its mass will be acting downwards. Okay, its weight, not mass, its weight will be acting downwards in this direction. Now this mg has two components. This will be one component and this will be one component. Okay. Okay, so now we have to find why this and this, why this is not one component and this is not one component. See, we can place the coordinate axis anywhere and you have to do that so that you get the angles properly and you get the resolution properly. Like this mg vector, mg force is like this. So you could have said that mg is in the negative y direction simply, so we don't have to find the components. But it's not like that. You have, this is angle theta. So angle theta is like this. See? Here you have angle theta. So you don't know that, you can't say that mg is in the y direction. It's not. Where you have to take the axis, you can take the axis like this at this point M, at the center of mass of M. So you can place the axis like this, like I've placed. Let us say this is the x-axis, this is the y-axis. Okay, you can place the axis anywhere. Take this xy axis like this. You can take the xy axis like this. You can take the xy axis like this. Okay, you can take the xy axis like this. Anyhow, you can place the axis. It's just that with respect to this axis, you have to state the vector direction. Okay, so here our x and y axis are like this. Now this is vector mg, or this is force mg, and now this mg has to be resolved into its components. So what is the angle? We don't know the angle. So this can be found out easily. If I extend this mg like this, then this triangle is a 90-degree triangle because this is perpendicular to this. In this triangle, this is 90 degree, this is theta. So this angle will be what? Because this is parallel, this x-axis is parallel to the incline. So this angle is what? 90 minus theta. Right? In this triangle, this is theta, this is 90, so this will be 90 minus theta. Now here see, in this inclined plane, this is x, this is y. So this x and y are 90 degree to each other. Now if this is 90 minus theta, then what will be this? Because this is, these two angles are again 90. If this is 90 minus theta, then this remaining angle will be theta. Okay. So what have we got? This is, if this is the x-axis, this we take as the y-axis, and this angle is theta, then we get this angle also as theta. See here, again I'll show you. Again, if you have any confusion, see, this is angle theta, this is mg. Okay, this is the x component, this is the y component. This is angle theta, we know. In this triangle, this is angle theta, this will be 90 minus theta. Now this is 90 degree again. If this is 90 minus theta, so this remaining is theta. Right? So we got this angle as theta now. That means here theta angle is made with this y-axis. Okay? And x-axis is perpendicular to this axis. So mg cos theta will be this component. This will be mg cos theta, and the perpendicular one will be mg sin theta. Okay? So this is how we get the components. Right? So this kind of inclined plane questions are very popular in your physics, and you will get to resolve these components in the next chapter only. Motion in a plane, in an inclined plane. Okay, motion in a plane. So this is all about resolution of vectors. You will have many more questions. Please go through them from your book NCERT and try to solve resolution of vector problems. Okay. The next topic we will study unit vectors, and I will show you how to resolve unit vector also in the components. Thank you.